Are we running out of water? And how can you change your water consumption? This and more on today's episode. I'm Valentina and welcome to my Life Without Plastic. Hello friends and welcome to another day in my Life Without Plastic. Today we'll be talking about something super important, may I even say essential. That's right, we're talking about water. And today is actually World Water Day. So happy World Water Day, everyone. I really think it's the perfect time for us to talk about this. And it's just such a nice holiday to have around and to make us a little more aware of all of our water consumption and the way we deal with water. And full disclosure here, I will be mentioning a lot of things that I myself am not really doing. As always, I want to be fully transparent with you. I always emphasize that this is my journey. It is not perfect, and I want you to know that we're in the same boat here. A lot of the things I will be mentioning are really things that are sometimes hard to resist or completely cut out of your life. But let's see, hopefully this episode will give us all the motivation to make some small changes. And again, I've said it before, but I could just never have enough of saying this. We are not here to live a perfectly sustainable life. We are building a community of a bunch of imperfect, badass people who are committed to living imperfectly sustainable. But together, we make a difference. So, don't forget that. Even if there's just one small thing that I mentioned in today's episode that you're already doing, that means you're doing more than many others. So, enough chatter. Let's jump right into all of the details because it's going to be a lot of information and I want to make sure I keep this episode not too long. So today we're going to fully dive into it. We're not easing into the topic, but literally jumping off the cliff into the ocean here. So here are some weird facts I found out that I think are pretty cool. And I really wanted to start with some fun facts about water, just so we can emphasize how unique water is compared to any other natural resource or substance, not just natural, but in general, anything else out there. So let's get started. First one. There is the same amount of water on Earth as there was when the Earth was formed. The water from your faucet could contain molecules that dinosaurs drank. Isn't that cool? While the amount of fresh water on the planet has remained fairly constant over time, obviously continually recycled through the atmosphere and back into our cups, the population has exploded. This means that every year, competition for clean supply of water for drinking, cooking, bathing, and like a sustainable life in general just gets tougher. And we'll talk about water scarcity in a few, but let's continue with the fun facts first. The second one. Nearly 97% of the world's water is salty or otherwise undrinkable. Another 2% is locked in ice caps and glaciers. That leaves us with just 1% for all of humanity's needs. All its agriculture, residential, manufacturing, community, and personal needs. Just 1% of all of the water on Earth. I think that's so insane just thinking about how much water is really unexplored on Earth. Like just thinking about the depth of the ocean and like even like the glaciers, there's so much water that we haven't even begun closely to explore in any way. So anyway, let's continue with the next one. I just want to get through those fun facts first before we jump into the details about water. Water regulates the Earth's temperature. It also regulates the temperature of the human body, carries nutrients and oxygen to cells, cushions joints, protects organs and tissues, and removes waste. So it's safe to say water does not have one single function. It's essential in just so many different areas of life, from the smallest to the largest tasks imaginable. 75% of human brain is water, and 75% of a living tree is water. And this fun fact is going to come handy a bit later, so don't forget it. We're going to talk about water memory, and I think it's interesting knowing that the human brain and a living tree both are composed of roughly 75% of water. A person can live about a month without food, but only about a week without the water. And this fun fact is actually funny because honestly, I feel like I'm one of those people that barely drink water, and I know this is terrible. We should be drinking so much more water than most of us do. But it's funny knowing, I mean, not just funny, it's also scary knowing that the human body can only go about a week without water. It just makes you think so much more about how precious and valuable it is for our body and for our needs, like our genuine needs. Water is part of a deeply interconnected system. What we pour on the ground ends up in our water, and what we spew into the sky ends up in our water. Which again is super interesting that we always talk about the water cycle. But at the same time, I feel like we never spend any time thinking about how water first originated on Earth. So we have to also ask ourselves, how did it come to be in the first place? Not just understand the cycle of it, but how did water come to be? The average total home water use for each person in the United States is between 80 and 100 gallons a day. 80 and 100 gallons of water a day. And in that regard, the average cost for water supplied to a home in the United States is about $2 for 1,000 gallons, which equals about 5 gallons for a penny. And we're going to talk about how much water we use in a bit, but I thought those were some really cool facts to just look at and explore. I think it's interesting seeing how diverse water can be, depending on what topic exactly we discuss. But this whole thing that water is essential in so many areas only makes me wonder, how much water do we really have left to use? I mean, as you see from all these facts, it just shows that water is essential for so many areas of life, not just one single purpose. So it kind of gets in my head, like, are we running out of it? What's happening? Seems like we're using so much, and is there a timeline? When will it run out? Is it already running out? How much water is there on Earth? Like, all of these questions are just bubbling in my head. So, Earth is special because it has so much water. It's in the ground, forms big oceans, and it's in our atmosphere. It's also in living things. Our bodies are made up mostly of water. Water covers 71% of Earth's surface, and almost all of it, 96.5%, or more or less 97%, is salt water. Salt water has different kinds of salt in it, but it mostly has sodium chloride, which is basically the same salt we add to our food. Just 3.5% of the water on Earth is fresh, and it's actual water that we could drink. But most of that fresh water is trapped in ice and glaciers. To put it into perspective, out of all water that is drinkable, 68% is trapped in glaciers and ice. A third of the fresh water is in the ground. We call it groundwater. And the last 2% of fresh water is in the rivers, lakes, and streams. A very small amount is in our atmosphere, where it exists as water vapor. That's what clouds are made of. If you took all of the water on Earth and put it together, it would be a ball of 860 miles wide. All of Earth's water would be a ball that would be 860 miles wide. That's a lot of water, but at the same time, putting into perspective, like, it's limited, right? Like, it sounds like a lot of water, but it also sounds limited. But some people are definitely claiming so that we're running out of time. 2040 is sort of marked as a milestone of when water will become extremely scarce, and if we don't change our ways of dealing with water, that is. And if you think about it, I feel like it does make sense. We have the same amount of water, but so much more population. Agriculture and farming also need water. For example, does it take 24,000 liters of water to produce just 1 kilogram of chocolate and more than 15,000 liters of water to produce 1 kilogram of beef? And if that's the case, how much water are we spending in all of that agriculture and farming? So a cotton shirt, for example, requires 3,000 liters of water. So fashion is another area that affects water consumption. So as you see, it's not just the water that we personally consume in our homes, right? We're talking about the water needed to produce food, and not just essential food, but just, food that sometimes we just like and enjoy. It's not necessarily essential to our survival, but we live in a society where we like enjoying different kinds of things, regardless of how much they are necessarily needed, right? So that being said, most of the water, over 90% actually, we use as what it's called virtual water, meaning it is water used all over the world to produce the food and products we buy. And buying food and products from companies that are responsible with the way they manage water does make a difference. I think it's super important to emphasize that. It's easy to forget that we also use water in ways we don't see every day. And sometimes things we don't see, we tend to just overlook and not really take into consideration. Water is used to grow our food, manufacture our favorite goods, and keep our businesses running smoothly. We also use a significant amount of water to meet the nation's energy need. So, how much water do regular daily tasks actually consume? I'm going to read through some of them, and you're more than welcome to check out my blog where I'm going to post this as well, and you can look at it in more details yourself. But for example, a full tub when you're taking a bath is about 36 gallons. 3 gallons per flush when you flush the toilet. So if you're flushing 6 to 8 times, that's about 18 to 24 gallons. A 10-minute shower, that's about 2 gallons per minute. So that's 20 gallons for a 10-minute shower. And let's be honest, a lot of us take much longer than 10 minutes in the shower, especially when those creative thoughts or different kinds of thoughts jump into your mind. It's definitely more than 10 minutes. A washing machine uses 15 gallons, a load. And depending on the efficiency of dishwasher, 4 to 10 gallons. Hygiene, such as washing face, brushing teeth, and so on, 2.5 gallons. And obviously, drinking water, consuming it personally, a gallon a day. And don't come at me saying you don't drink a gallon a day and that's why you save water. That's actually not a good thing. You shouldn't be saving your water consumption from the actual recommended amount of how much water you're drinking. And I'm guilty of that as well. But feel free to check out this page and read through the actual facts in more details. But other than personal consumption, right, in our very own homes, fashion, for example, is undoubtedly a thirsty industry. And nobody can really argue against that. I mean, according to the Ellen MacArthur Foundation, textile production uses around 93 billion cubic meters of water annually, the equivalent to 37 million Olympic swimming pools. 37 million Olympic swimming pools. That's how much water the textile production uses in one single year. I think that's a very crazy number. Water consumption on that level is felt specifically in dry regions. First and foremost, the impact is felt by those communities where production is occurring. Alexis Morgan, Worldwide Fund's Global Water Stewardship Lead, tells Vogue. There are issues around access to water and sanitation. But it's not just water consumption that's an issue when manufacturing clothes. Pollution and the actual polluting of waterways is also a major concern. In fact, an estimated 20% of global wastewater is caused by dyeing and finishing processes in the fashion industry, according to a 2012 report. It prevents people using those waterways. Certain chemicals used in dyeing processes can be problematic. For example, use of chromium, which is part of the textile processing. And pesticides can also affect local drinking water. I think you get the hint. We are being awfully irresponsible with the way we use water. And I think that regardless if you believe that water would potentially run out or not, everyone can recognize the wasteful ways we deal with water. I mean, there are communities right here in the United States that go through severe drought seasons. As of August 2020, it was reported that 1/3 of the country is experiencing at least a moderate level of drought. Much of the West is approaching severe drought, and New England has been unusually dry and hot. An estimated 53 million people are living in drought-affected areas. And here's also a map that you can check out on my blog if you're not watching this on YouTube. It shows conditions in the continental United States as of August 11, 2020. And as reported by the U.S. Drought Monitor Program, a partnership of the U.S. Department of Agriculture, the National Oceanic and Atmospheric Administration, and the University of Nebraska-Lincoln. The map depicts drought intensity in progressive shades of orange to red and is based on measurements of climate, soil, and water conditions from more than 350 federal, state, and local observers around the country. NASA provides examples and experiments, measurements, and models to this drought monitoring effort. According to the Drought Monitor, more than 93% of the land area in Utah, Colorado, Nevada, and New Mexico is in some level of drought. And 69% of Utah is in severe drought, as is 61% of Colorado. More than 3/4 of Oregon, Arizona, and Wyoming are also in drought. The effects of severe drought include stunted and browning crops, limited pasture yields, dust storms, reduced well water levels, and an increase in the number and severity of wildfires. Most of those areas had no signs of drought in the midsummer of 2019. So there's actually a map that you can monitor regularly. You can, again, find the link of that map in my blog as well. It actually allows you to click on different areas of the United States and see the drought conditions there pretty much real time. So as of March 16, 2021, a very big part of the West in the United States is marked as D4, which is exceptional drought. So if you're interested in reading something more detailed, feel free to check out this interactive map. But of course, it's not all bad. Humankind has worked on creating different inventions that help us with water conservation, and I do want to highlight them as well. I don't want them to go unnoticed, and I don't want us to only focus on the problem and the bad consequences we're seeing. So the first one is a very obvious one, which is water treatment. So a quick history lesson of how we started treating water. Well, in ancient Greek and Sanskrit writings dating back to 2000 BC, water treatment methods were recommended. People back then already knew that heating water might purify it, and they were also educated in sand and gravel filtration, boiling, and straining. The major motive of water purification was better tasting drinking water, because people at that point could not yet distinguish between foul and clean water. Turbidity was the main driving force between the earliest water treatments. Not much was known about microorganisms or any chemical containments at that point. So after 1500 BC, the Egyptians first discovered the principle of coagulation. They applied the chemical alum for suspended particles settlement, and pictures of this purification technique were found actually on the wall of the tomb of Amenophis II and Ramses II. After 500 BC, Hippocrates discovered the healing power of water. He invented the practice of sieving water and obtaining the first bag filter which was called the Hippocrates sleeve. The main purpose of the bag was to trap sediments and that caused bad taste and odors. In 300 to 200 BC, Rome built its first aqueducts. And then during the Middle Ages, 500 to 1500 AD, water supply was no longer as sophisticated as before. These centuries were also known as the Dark Ages because of the lack of scientific innovations and experiments during that time. So then in 1627, this is like a big jump from the previous developments. The water treatment history continued as Sir Francis Bacon started experimenting with seawater desalination. He attempted to remove salt particles by means of an unsophisticated form of sand filtration. It did not exactly work, but it definitely paved the way for further experimentation by other scientists. And I'm going to fast forward through history a little bit because I don't want to spend too much time on all of the details. And I'm going to go straight to when we started treating water with chlorine. The victory obtained by the invention of chlorination did not last long. After some time, the negative effects of the element were discovered. Chlorine evaporates much faster than water, and it was linked to the aggravation and cause of respiratory diseases. It would take until 1940s before drinking water standards applied to municipal drinking water. In 1972, the Clean Water Act was passed in the United States, and in 1974, the Safe Drinking Water Act was formulated. The general principle in the developed world now was that every person had the right to safe drinking water. Starting in 1970s, public health concerns shifted from waterborne illnesses caused by disease-causing microorganisms to anthropogenic water pollution such as pesticide residue, industrial sludge, and organic chemicals. Regulation now focused on industrial waste and industrial water contamination, and water treatment plants were adapted. Techniques such as aeration, flocculation, and active carbon absorption were applied. In the 1960s, membrane development for reverse osmosis was added to the list. Risk assessments were enabled in the 1990s. Water treatment experimentation today mainly focuses on disinfection by products. An example is, for example, the trihalometane, trihalometane formation from chlorine disinfection. So these organics were linked to cancer. Lead also became a concern after it was discovered to corrode from water pipes, and the high pH level of disinfected water enabled corrosion. Today, other materials have replaced many lead water pipes. So as you see, water treatment has gone through so much development over the years to ensure that water is safe to drink. And now we believe that every human being has the right to clean water. And to make sure that we're on the right path to making access to clean water a fundamental right, there have been numerous projects trying to provide clean water to rural areas. One of those inventions is the fog catcher. As in most of rural Morocco, climate change and population pressures have led to more unpredictable rainfall patterns and the depletion of natural water sources. In recent years, repeated cycles of intense drought followed by flash floods have led to deaths and the devastation of local infrastructure. However, the Sidi Ifni region does have one precious resource: fog. On average, it experiences 143 days of fog a year. And over the past 10 years, Darcy Mott has erected vast mesh nets to capture the moisture at an altitude of 1,225 meters on the slopes of Mount Mesgida for what is now the largest fog harvesting project in the world. About 600 square meters of mesh nets capture water particles from the fog, which then condense and drip into collection trays. Roughly 6,300 liters of water can be harvested daily. The water is then filtered and mixed with underground water. More than 8 kilometers of pipelines have been installed to share the water between about 400 people in 5 different villages. And the benefits are obvious: relatively clean water that is both instant and free. The population used to spend at least 4 or 5 hours going to collect water every day from wells in neighboring villages, or collecting the train in tanks during the rainy season. The idea of harvesting fog was first developed in South America in the 1980s, and there are other projects in Chile, Peru, Ghana, Eritrea, South Africa, and California in the United States. In 2017, Darcy Mott plans to start installing the next generation of bigger and better cloud fisher nets developed in Germany. These larger nets will double the amount of water collected and connect another 8 villages to the network. Also, as we talk about, a very small percentage of fresh water being available to mankind in general, I think that it's important to emphasize this next invention. So, as I mentioned, roughly 97% of all water on Earth is salt water, and hence we can't drink it. Just a few years ago, in the middle of its worst drought in 100 years, Israel's water reserves were approaching the red line. Now it has a surplus. The country's water revolution was accomplished through a combination of a national campaign to conserve and reuse dwindling water resources and a new wave of state-of-the-art desalination plants. In 2007, low-flow toilets and shower heads were installed nationwide, and the National Water Authority built innovative water treatment systems that replaced 86% of the water that goes down the drain for irrigation use. Hard-hitting television ads featured well-known personalities, hammered home the message Israel is drying up as the skin on the actors began to crack up. Water conservation became fashionable, and parents urged their kids to take quick showers, saying that the Sea of Galilee, Israel's main source of fresh water, was running out of water. Domestic water consumption fell by 18% after the campaign, but that was not enough. Israel continued to take water conservation actions in many other areas, anything from agriculture, farming, to anything you can imagine that water is needed. The major breakthrough, though, came with desalination, the process of removing salt from seawater. Desalination works by pushing salt water into membranes containing microscopic pores, and the water gets through while the larger salt molecules are left behind. Israel's first desalination plant was built in Ashkelon in 2005, and today up to 80% of water for domestic use flows from large coastal desalination plants. So I think that's a great example of making the best out of the situation, right? But I think it's important to also recognize that they didn't simply invent a new way of producing clean water, but they also encourage people to change some of the ways that they personally were using water. I think that's an integral part of the process. Change does not only come from the government or whoever coming up with a new invention. Change also comes from each individual person. And I think that this is a great example for that. So how can you help? What can you do to help ensure that we don't run out of water? The good news is for you that there's plenty of ways to contribute. And remember, every small step contributes to the bigger cause. So even the smallest change you commit to make can have an immense impact. Don't forget that. Well, one of the very obvious ways of helping is through fashion. As I mentioned before, we talk about the virtual water that we use and water consumption that we don't see but are still responsible for. So shopping secondhand can definitely be an amazing way to make sure that the clothes already produced are given a second life and can help reduce the mass production of fast fashion. So that could be an amazing way of contributing to the reduction of water consumption. But if you're not really into thrifting as much as, you wish you would be, it's just not for everyone. You can also opt for example, organic cotton clothes. Organic cotton uses 91% less blue water, or what is basically groundwater, such as freshwater lakes and rivers and so on, than conventional cotton. So you can also do some research into some more sustainable companies. You can find out how they deal with water, if they actually use less water for the clothing production, if they are conscious about the materials that they source overall, and so on. So fashion can definitely be a very big area that can help your reduction of virtual water, right? Like when we think about reducing our water consumption, we just think about, oh, close the faucet, don't take baths. But that's another way of reducing our water footprint, if we can call it so, right? Like through fashion, for example. And besides fashion, there's obviously many other ways of reducing your water usage at home. I'm not gonna read through all of them. I'm just gonna highlight some, but feel free to check out the page and read through all of the tips on how you can save water. One of the main ones is fixing leaks. Small households leaks can add up to gallons of water lost every day. That's why Water Sense reminds Americans to check their plumbing fixtures and irrigation systems each year in March. So leaks can be a very big wasteful way of just really wasting water. Like there's no other way to say that. In the bathroom, what can you do to reduce your water consumption? Well, you can turn off the tap while shaving or brushing your teeth. I'm sometimes guilty of this. I would brush my teeth and leave the faucet running. It's definitely something that is a very easy change. It's not even an inconvenience. In the kitchen, you can use a dishwasher, and when you do, make sure it's fully loaded. In the laundry room, make sure that you only wash full loads of laundry and use the appropriate water level or load size, depending on your machine. I can honestly say that that's one of the best things that I'm doing when it comes to water reduction, because I'm so lazy when it comes to doing the laundry that I just wait until my basket's more than full and my loads are always full. So I definitely don't waste water with the washing machine there. In your yard, you can definitely invest in some more water-friendly products, like sprinklers, that are smart about the water usage and don't just waste water. You can make sure that you place them in the right places so that the water that's coming out is actually being used properly for your plants or your yard needs. Other outdoor ways of reducing water, make sure you sweep driveways and sidewalks. And instead of just hosing it off, you can just sweep it if it's not that dirty. You don't have to use water there. And when you wash your car outside your house, you can also just use water from a bucket instead of having a hose like consistently running. So those are just some tips, right? Like I definitely read through the site. I think you can find a lot of useful information on other things that you could do to save water. But I just wanted to emphasize that there's just so many different ways. Anything from something physical that you can see, like turning off the faucet, to something virtual, as we call it, right? Like your fashion, even like the products you buy, like veggies and fruits, like what farms do they come from? Are the farms more conscious about water consumption and so on? I think all of these are amazing ways of helping the cause. And again, like it doesn't matter if you do something small or something big. Not everyone is gonna come up with the next big invention. So even something as small as taking a shorter shower or turning off the faucet while you brush your teeth can help and have an immense impact. But alright, we've been waiting long enough for this, so now it's time for some conspiracy. And I'm not drinking tea today, I'm drinking water in support of World Water Day. But good news, today I've prepared actually not one, but two whole theories. Let's just jump right into them because I don't want to hold you off much longer. First one, water memory. Water memory is the ability of water to retain a memory of substances previously dissolved in it, even after a number of serious dilutions. It has been claimed to be a mechanism by which homeopathic remedies, aka alternative medicine, work, even when they are diluted to the point that no molecule of the original substance remains. Water memory contradicts current scientific understanding of physical chemistry and is generally not accepted by the scientific community. In 1988, Jacques Benveniste published a study supporting a water memory effect amid controversy in Nature, accompanied by an editorial by Nature's editor, John Maddox, urging readers to suspend judgment until the result could be replicated. So, in the years after publication, multiple supervised experiments were made by Benveniste's team, the United States Department of Defense, BBC's Horizon program, and other researchers, but no one has ever reproduced his results under controlled conditions. And I want you to understand how important this was when they published, like the only way for them to publish his study was if the editor, Nature's editor, would write a note telling readers to basically not believe that. So I think it's important to keep that in mind. And he was not really the only one who tried to prove water memory. Recently, actually, a new groundbreaking discovery has been made within the most basic of resources. Scientists have just discovered that what they call the discovery of the millennium, and a huge revelation in human consciousness. Scientists from Germany now believe that water has a memory, meaning that and I'm sorry, I have to cut it off here. When we talk about scientists, I feel like sometimes people just like, everyone's a scientist. So again, like in general, the scientific community does not recognize this, but other people who consider themselves scientists, have the degrees to be scientists, they claim otherwise. Just to clarify this, because I'm throwing the word scientist out there, I don't want you guys to think that just because someone is called a scientist, they necessarily are credible and have to be believed, right? But scientists from Germany now believe that water has a memory, meaning that what once was seen as a simple commodity has now been closely examined to reveal a scientific revelation, uncovering a mind-blowing truth. So by examining individual drops of water at an incredibly high magnification, scientists were able to physically see that each droplet of water has its own individual microscopic pattern, each distinguishable from the next and uniquely beautiful. A scientific experiment was carried out whereby a group of students were all encouraged to obtain one drop of water from the same body of water all at the same time. And through close examination of the individual droplets, it was seen that each produced different images. And a second experiment was then carried out where real flour was placed into a body of water, and after a while, a sample droplet of the water was taken out for examination. The result produced a mesmerizing pattern when hugely magnified, but all of the droplets of the water looked very similar. When the same experiment was done with a different species of flour, the magnified droplets looked completely different, thereby determining that a particular flour is evident in each droplet of water. Through this discovery, which shows that water has memory, according to scientists, a new perception of water can be formed. The German scientists believe that as water travels, it picks up and stores information from all of the places that it has traveled through, which can thereby connect people to a lot of different places and sources of information when they drink this water, depending on the journey that it has been on. This has even been compared to the human body, of which each is incredibly unique and has an individual DNA unlike any other. And while the human body is made up of 70% water, conclusions could be drawn from these new discoveries that human tears can hold a unique memory of an individual being, through the body's store of water hosting a complete store of information that is linked to individual experiences, suggesting that everyone is globally connected by the water in the human body, which travels through ongoing journeys, whereby information along the way is always stored. So I think it's such an interesting theory, right? That water pretty much saves all information wherever it travels through. What if we were able to access that information and literally learn the secrets of the universe? Maybe our brains could just not analyze or unlock or simply comprehend that information until now that travels through water. So I don't know, I feel like it's a plausible theory, even if the scientific community is sort of against it. I feel like, why not? I mean, water is so unique and so powerful. It could most likely store all the information out there. So let's check out the second theory. And this one's about Mars. This is a National Geographic article from 2013. Did life begin on Mars and then travel to Earth for its blossoming? A long debated and often dismissed theory known as panspermia got new life in the past week, aka 2013, as two scientists separately proposed the early Earth lacked some chemicals essential to forming life, while early Mars likely had them. Last week, during a keynote talk at the Goldsmith Conference for Geochemists in Florence, Italy, Benner said that two elements that allow the precursors of life to form were almost certainly unavailable on Earth, but were likely present on early Mars. Basically, we went looking on Mars because the origins of life options on Earth just aren't looking very good, Benner said. One of the stumbling blocks of life started on Earth is the fact that water is almost universally accepted as necessary for the onset of life. Yet RNA, which many consider to be the earliest expression of genetic replication and another essential precursor to life, as we know it, falls apart if you try to build it in water. What keeps that from happening, Benner has found over the years of study, is the presence of a form of the element boron. While geologists say boron was too scarce on early Earth to support any widespread creation of RNA, it was seemingly more abundant on early Mars. One sign of its presence on the red planet is that at least one meteorite has delivered some Martian boron to Earth. So the question arises, did RNA on Mars lead to actual DNA-based life? And did those life forms then travel to Earth on rocks kicked up when a meteorite struck Mars? A few days after Benner's talk on August 29th, a paper appeared in the journal Nature Geoscience that made a similar argument about phosphorus compounds, which form the backbone of RNA, DNA, and proteins. While phosphates were present on early Earth, said lead author Christopher Adcock of the University of Nevada, Las Vegas, they were most frequently found in a solid state in which they are most stable. Yet biology is understood to have started in water, which would have contained little of the phosphates on early Earth. This has long been called the phosphate problem. Adcock said in an interview, there are theories out there about how it might have worked on early Earth, but there's no consensus. So, I feel like this makes the entire concept of water even more complex. We think it's essential for life, but at the same time, there are numerous essential chemical reactions that are prevented by water. So it definitely raises the question if life on Earth came from maybe someplace else. What do you think about both theories? I think that both are pretty cool to fantasize about, even if there's nothing much to them. I'm Pisces, so my brain tends to make up stories about everything I hear. But let me know what you think about water. Do you think it's essential that we rethink the ways we use water and how much we consume, considering that there are literally people out there who don't have access to clean water? Do you feel like any of the tips that we explored today are actually useful? Do you think it's important to preserve water? Or do you feel like it's never gonna end? It's something that's always gonna be the same? I don't know. I would love to hear your thoughts on that. Definitely stay tuned for my next week's episode. We're gonna explore where your donated clothes go. We'll follow the trail and see if you know everything about donating clothes and other products. But that's all for today. See y'all later. Bye!